Hi there. Let's unpack some of the facts from our last conversation on artificial intelligence. MFA started us off with a great question. Is AI more about math or computer science? The truth is, it's both. Mathematics provides a theory, logic, and structure that makes AI work through calculus, linear algebra, and statistics, while computer science gives us the tools to turn those ideas into functioning systems that bring it all to life. One builds the foundation, the other builds the structure on top. When it comes to AI, you really can't have one without the other. We also talked about large language models, or LLMs. These are the powerful systems behind modern conversational tools like ChatGPT. They rely on a type of deep learning architecture called a transformer, which allows them to understand and generate text in remarkably human-like ways. They are trained on vast amounts of data, which allows them to learn and recognize the patterns and relationships within language, so they can perform tasks like translation, summarization, or even answering your toughest questions. On that note, MFA thought the transformer model might have appeared in the 20th century. A close guess, but it's actually more recent. The transformer architecture was introduced in 2017 through a landmark Google research paper titled, "Attention is All You Need." It changed how AI models process information. Instead of reading sentences one word at a time, transformers read them all at once, allowing for faster, more sophisticated language understanding. We also touched on reinforcement learning. MFA described it brilliantly. And to add more context, it's the method where machines learn by trial and error. Using rewards and penalties to improve performance over time, AI systems can train themselves to play video games, master chess, or even navigate self-driving cars. Each success reinforces the right behavior, and each failure is a lesson learned. Nia Sean mentioned that the history of AI goes back to Frankenstein. While the story does reflect humanity's fascination with creating human-like intelligence, the actual history starts elsewhere, with Alan Turing. Long before computers as we know them existed, Turing theorized about machines that could think, reason, and improve beyond their original programming. He also proposed a way to test that idea, the imitation game, now known as the Turing test, which measures whether a machine can convincingly mimic human thought. That brings us to the question, has any AI actually passed the Turing test? Well, in some cases, yes. Some of today's advanced systems, like GPT 4.5, have managed to fool human judges under controlled conditions. In one study, participants even rated the AI as more human than real people. That's proof that the line between human and machine conversation is getting more blurry by the day. MFA also raised the idea of randomness in AI. Randomness is actually an important ingredient. It introduces variation during training, helping AI models diversify their learning and avoid becoming too predictable. It also helps models to avoid bias. This is controlled unpredictability, enough chaos to make systems smarter, but still stable enough to repeat results when needed. And finally, Nia Sean shared a fascinating story about a country benefiting from AI. The small Caribbean island of Anguilla happens to own the internet domain .ai, which has become highly sought after by tech companies and startups. In 2024, revenue from domain sales brought the island about $39 million, nearly a quarter of its entire government income. Today, there are more than 850,000 .ai domains worldwide, a huge leap from fewer than 50,000 just a few years ago. And that's your fact check for this episode. A reminder that AI isn't just about algorithms and code. It's also about human creativity, curiosity, and occasionally some unexpected economic benefits. Catch you next time for another episode of How Did We Get Here?